Everybody? Welcome everyone to ChainSafe's CSCON 1. My name is Tim. I am from ChainSafe, and I will be your MC for this morning from 9 a.m. Eastern to 12 p.m. Eastern, at which point Jimmy Johnson, Jimbo J, Jimbo Slice, J Guitar Boy will be taking over from 12:30 p.m. Eastern. Our 3-day Web3 extravaganza will be running today through to Friday, December 3rd, every day from 9 a.m. Eastern to 4 p.m. Eastern. Funny enough, CSCON 1, believe it or not, is our second ever iteration of this virtual summit. We kicked off last year with CSCON 0, so har, we managed to add a bit of programming humor there. We have an absolute smoker of a lineup this year, and I'm personally incredibly excited for everyone that will be tuning in from Remo, from YouTube Live, or watching these at a later date on our YouTube channel. You can find our full event program over at cscon.chainsafe.io. That's cscon.chainsafe.io, or the agenda if you're currently watching from Remo. So some quick reminders before we begin. If you are a registered speaker, please do not unhide your camera. Please do not unmute your microphone. Please do not start a whiteboard. Please do not share your screen. You will interrupt someone else's presentation. Second, there is a Q&A tab where you can ask your questions to our speakers. Please ask your questions there and upvote the ones you want answered first. We also have a linked event called the CSCON 1 networking floor. At any time, if you want to meet with some ChainSafers or network with other attendees away from the presentation floor, you can click on the drop-down menu in the top left-hand corner that says Events, and then go to Other Related Events. You can use this function to hop in and out of the presentation building and the networking building, so do that. What point are we on? Number 4. We also have networking from 4 p.m. Eastern onwards after all of our talks today. So stick around after the event. It'll be fun. Let's just chat, unhide your cameras, unmute your microphones, but not during a presentation. And then finally, ChainSafe is hiring. Go to chainsafe.io/careers if you want to join us in building the brazen future of Web3. And also if you want to just join a fun, cool gang like us. That's it for my opening notes. Today, we have an amazing lineup of speakers. First off, we have Aiden with an opening keynote. So Aiden Hyman is a co-founder and CEO at ChainSafe. Aiden opened last year's CSCON 0 keynote with an emphatically value-driven message that has reverberated in my work personally through the year. I quote him from last year, "Collaboration is good for the whole garden," end quote. Last year, he implored us as stewards of this budding space to take on a positive-sum approach and to see value beyond the zero-sum thinking that has typically permeated the early crypto space, but also the Web 2 and traditional world. And with that message, Aiden set the stage for ChainSafe in 2021. We were collaborators through and through with all of our foundation partners, blockchain peers, individual contributors, and more. If composability is the ethos of the open source and Web3 movement, our work was going to build on that relentlessly. So with all that said, I now invite Aiden on stage to officially welcome us into CSCON 1, deliver his opening keynote, and set the stage for 2022. Aiden, you may take the stage. Yeah.
Hello, everyone. Good morning, good afternoon, and good evening, depending on where you're joining us. Okay, let's see how this works. Perfect. Awesome. So yeah, welcome to our second conference. Perfect, it's working. We're incredibly excited to be kicking off our annual conference, and we're just so thankful to have all of you here with us today. Everyone from our speakers to our attendees, and of course the CSCON Planning Committee. Oh, I see the mouse is there, unfortunately, but that's gonna have to stay. So I know that there are many people listening who know the values ChainSafe holds. And you know, a lot of you have been with us since the beginning of our journey. But for folks here who are joining us new to the blockchain space, and are really just joining us on this journey, and that, we are just beginning this journey. We're so thankful to have you here today. And I'd like to really take a moment to share with you our core objective and the principles that guide us each and every day. So what is this, event? This event for us is really about accelerating the growth and adoption of Web3. And we are staunch believers that we can make this happen a lot faster if we work together. And so this conference is really an attempt at bringing together all of the incredible ecosystem partners and community participants that we believe are making a true contribution towards the future of Web3. And so this is an opportunity for all of us to learn from one another and share what exactly what exactly we're working on. And it's really important to acknowledge that we started out as being a group of people just hanging out at our local Ethereum developers meetup. And from that, we've grown to a company, over 100 people that are contributing to communities now all over the world. And we're just so thankful to have talks from our friends contributing to Filecoin, Mina, Ethereum, and other incredible projects like Polkadot and beyond. And so what have we done in 2021? Well, in 2021, we've done an incredible amount of work, and we've achieved so much more than we ever could have imagined last year at CSCON. And really, the numbers speak for themselves. We've gone from this community-driven kind of group of people to really having an effect on so many different communities all over the world. You can see everything from the core implementations we're working on, to our audits, to our partner projects that we've contributed to one way or another. And of course, the organizations using our Metaverse SDK, which is a first step for us into unlocking what we believe is equitable access to the Metaverse. And so this is what we look like right now. We're in 28 countries with over 100 chain safers distributed all over the world. I mean, you can see for yourself, we're really everywhere. And so no matter where you are right now tuning in, there's probably people pretty close to you that would love to call you a colleague. So really, we are a remote first team, but that has a presence in a significant amount of countries and are constantly looking to expand the teams in these different places. Awesome. And yeah, this was us at ETH Lisbon. And, it was an opportunity for so many of us to meet for the first time. There were close to 40 of us, and we just had such an incredible time being together and just sharing, and such an incredible experience. So what have we done since last CSCON? As you can see, we went from 34 people to 105. But beyond that, beyond just this number, we've done so much, from expanding to different places, to opening up offices all over the world. Really, this has been a year of laying down the foundations, laying down the core kind of infrastructure to really accelerate everything we're doing, beyond just building really cool things, but truly bringing also our products to the real world, as we've seen with the Metaverse SDK going live. It's just been an incredible year of not only growth on the organizational level, but also on the product side of things as well. So what are we really at the end of the day doing, and how do we achieve those things? So really, we have two guiding principles that really kind of direct us in everything that we do. So when evaluating what projects we choose to work on, we evaluate the technologies underpinning them on a variety of factors. This allows us to focus our efforts on projects that we truly believe, on an objective technological level, are achieving incredible things. This also allows us to provide our engineers with challenging and fulfilling work that's constantly making us have to learn new skills and go beyond what most are doing in their day-to-days. Being able to work on these interesting cutting-edge technologies is an incredibly motivating thing for us to be able to do each and every day. Our second guiding principle is our belief that focusing our efforts and energies into open source technologies is really what is going to bring us to a truly empowered Web3 future. Working alongside our partners, we've been able to develop technologies that have benefited the entire ecosystem in which they reside and have advanced it faster than we could have ever imagined. So now just to briefly mention a few of the different projects and products we're working on, but also just to shill my colleagues so that you can maybe spend some time really learning about these things from them directly. So first we have Forest, which is our Rust implementation of the Filecoin node, which you can hear Liraj talk about later during our conference. We have Golang, we have Gossamer, a Golang implementation of the Polkadot host, which Elizabeth Binks will be talking about later in our conference. We have Lodestar, our TypeScript implementation of Ethereum consensus, which Dapline will be speaking about. Mina Rust, which is our Rust implementation of the Mina protocol, which Lerna will be speaking about. We have Chainbridge, our cross-chain interoperability solution, which Taha will be speaking about. Our Metaverse SDK, which is bridging blockchain-based assets into any reality, of which Leon will be speaking about. Web3.js, which is the most comprehensive Ethereum JavaScript library, with a talk from Mike. And Files, where privacy meets convenience with encrypted file storage on Filecoin, with a conversation that Colin will be leading. And so really at the end of the day, the most important thing underpinning all of this is world-class engineers and leadership, really providing this incredible foundation for everything we do. And as you can see in these pictures, we really do try our best, as much as we are a remote-first company, to spend as much time as possible together, even though we live in a world that isn't always easy. And of course, I have to end with one of the most important slides, which is that we're hiring. And if you're passionate about pushing these boundaries of how we utilizing blockchain technologies can change the world, please check out our open positions at chainsafe.io/careers and just start a conversation and let's see what we can build together. And so let's keep in touch. Check us out on Twitter, send me an email, check us out on GitHub. But most importantly of all, please stick around and check out all the incredible conversations that we'll be starting and continuing during our conference. And really the whole goal of this is to engage with you, our community, and hear from you what you think. And so thank you for being here, and thank you for contributing to our journey.
Amazing, Aiden. Thank you so much for another wonderful opening keynote. Community is in our DNA, and I truly, truly believe that. And having these guiding principles driving us in our work and what we do, it's a powerful stage-setting thing for 2022, and I hope, we all deeply take in these messages. And kind of use it as guiding lights for next year. So let's go over to questions and answers and see if our audience have any questions. We got one question from Anonymous. Thank you, Anonymous. What was the hardest thing to do during such company scaling, Aiden?
Yeah, it's a really good question, and I think one which you'd get a different answer depending on who you ask. But I would say, personally, the biggest, I guess, unknown has really been COVID throughout all of this, and really, how we operate as a remote first company. I mean, previously to this, we would have a yearly gathering, we would have a lot more events to travel to and be together. So I would say the most unknown, right? The thing that you can't just read a book about right now, or at least you couldn't at the beginning of COVID, is how you scale a company in a remote first setting during a global pandemic. And so that was definitely very interesting. And I've just been so proud of the team, the ops team, and just how they've, managed to just do such an incredible thing.
Yeah, I have to second that sentiment. I can't imagine what it's like, growing and scaling a company during COVID-19 when there's not really a playbook for doing something like this for a remote first company, right? So totally. So, sorry for my Slack messages going off. Probably someone pinging me about their speaking slot later. But, oh, okay. Sorry about that. We have another question from Anonymous. Thank you, Anonymous. How do I book for an audit?
The best way to reach out to us about anything work-related is to check us out at info@chainsafe.io. Send us an email with all the things that you're looking to do and as much context as possible for us to be able to understand what it is you're really looking to do beyond just a couple sentences.
Awesome. And if there's any other questions from the audience, feel free to raise your hands now or ask it in the Q&A. But just again, to reiterate, that is info@chainsafe.io. That's INFO. You guys know how to spell info. Info@chainsafe.io. And yeah, give us all the context. Send us as much information as you can about your project, and we'll see. Oh, we got a question. Ding, 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 ding. Fiznik asks, why have you decided not to launch any of your product into the market? I mean, launching a token and linking it with the economies of the product.
Yeah, I mean, we've definitely had ample opportunity to launch a token, being in the space as long as we have, and we definitely believe that, our products will be able to achieve so much more by being technically objective and being able to interoperate across so many different ecosystems at the same time. And so by limiting kind of the the relationship between one chain to another, we believe we're empowering for much more potential possibilities beyond what is currently possible. So yeah, I mean, definitely not afraid of tokens, but I'm not anti-token, but for a lot of our products right now, kind of that path just doesn't necessarily align with the vision we have for the product.
Amazing. Thank you for that, Aiden. And thank you for your opening keynote. It's a wonderful start to CSCON 1. And yeah, we'll, thank you again for your time and your participation. Stick around for the rest of the talks and for the rest of the day.
Thank you, Tim. And thank you everyone for being here. And I hope you have a wonderful rest of these next 3 days. See you all in Reno land.
Bye. Awesome. Okay. Thank you, Aiden. And yeah, again, thank you to everyone participating and attending at CSCON. You guys are amazing. You guys are beautiful. I see all the amazing profile pictures at the bottom. And it's just, yeah, it's awesome to see such a strong showing for the opening keynote from Aiden. So just some reminders again before we move over into our next presentation. If you are a registered speaker, please do not unhide your camera, unmute your microphone, start a whiteboard, or share your screen. You will interrupt someone else's presentation. Got it? And yeah, make sure you ask your questions in the Q&A tab, or if you want to speak actually and unhide your camera and mute your microphone, then we can add you to the stage at the end. And yeah, definitely also make sure to check out the events drop-down menu. I think it's over here or over here. I'm not sure if I'm mirrored right now on video. To go to our networking building. If you want to kind of step away from the presentations, why would you? And you want to meet some chain safers and network with other people, then check it out over there. Coming up next, we have Alex Mueller from ChainSafe, actually. Alex Mueller is head of product at ChainSafe. Being a product guy since the time when it wasn't fancy, Alex discovered his passion for decentralization in 2015, thanks to IPFS. Now, before joining ChainSafe, Alex pursued his second passion in InfoSec. That's information security for the uninitiated, for fun and profit in a variety of product-related roles and organizations. When Alex is not staring at displays, he loves to read, he loves to hike and ride his gravel bike, and yeah. He'll be speaking to us about product in Web3 today. So that's product in Web3, same, but different. So Alex, I would like to invite you onto the stage. And yeah, feel free to unhide your camera, unmute your microphone.
Was emotional and intense. Yeah, really. Yeah, also thank you and welcome from my side by Aiden, our CEO. Actually, I myself have ChainSafe just joined about 3 months ago, so I joined quite in the mid of this really incredible journey of scaling and of new and exciting opportunities. And yeah, as Tim already mentioned before, that for the longest time I've basically been in Web 2 and watched Web 3 space more from the sideline. And now, since I basically went full in to Web 3, there's kind of some questions that constantly come to mind and kind of I'm constantly thinking about. And those two are basically, the first hand is how can we basically maximize our impact in terms of how can we bring mainstream. And the second one is how does this really differ to the Web 2 type products where there's basically a lot of examples of how transition to the mainstream looks like. Want to speak about today. So I want to use next 20 minutes. I hope I can share my screen again to share my thoughts on the topic. And ideally, I hope that we can have a discussion afterwards in terms of your points and your views on the topic. Yeah, so here we go. First question, maybe, what is this? Does anybody know what it is? Maybe you can answer in the chat window. And there's a small hint. It's no armadillo. I hope I pronounced it correctly. Yeah, it's definitely a bell curve, a normal distribution. That sounds right. So when you have a kind of a product and marketing background, then usually this looks also familiar to you, but not necessarily from a normal distribution type of association, but more like from the tech adoption lifecycle from Jeffrey Moore. That's actually something, or a model that is almost 30 years old by now, but still seems to be very valid. And I think it will be also valid for Web3, and basically describes how a new and disruptive becomes adopted by mainstream markets. And what you can see here is basically a curve, which basically shows 5 different stages, or that represent basically 5 groups of users that adopt the technology one after the other. And yeah, the bell curve basically symbolizes and shows that there's 2 very heavy segments in the middle, and there's quite some smaller segments on the outside. Yeah, these segments then are also associated. This is kind of part of the model, and I will use this model now to basically then show some of the unique twists, I think, to mainstream adoption for Web3. So I will now go a little bit more into detail what this model is about, and then we will dive in the second part a little bit more into specifics of Web3 in this regards. Yeah, so basically, as said, the curve or the distribution shows the amount of users joining or using a technology. And these 5 groups or stages that I mentioned in the life cycle, they have names. You can read here, they are called like tech enthusiasts, visionaries, pragmatists. And I think one of the really achievements in this model that Geoffrey Moore made is basically that he assigned kind of characteristics who are using technology for technology's sake. That means they are not really value driven. They simply like technology and like to spend time on technology. And then there's a second group of visionaries that are more like people that actually already see strategic advantages or benefits that they and basically want to be first movers, and that's why they start early with adopting a new technology. And then we have more other groups like pragmatics that already are very cautious in terms of, so they do not really like drastic changes and stuff like that. They are more like guys that want incremental improvements and very well laid out products. And then we have a 4th group and 5th group, which is then already sometimes considered as being more like the aftermarket. That means people that usually do not follow trends, that are very suspicious about new technologies, and that basically, hide as long as they can something new. So this whole cycle has basically shortened. Cycle, imagine this for an innovation, for example, like the telephone or another quite. Then this cycle could take multiple decades to complete, and even for products to reach or technologies to reach mainstream adoption. But this cycle has decreased drastically. So when we think about the internet already, then this cycle has decreased to, I think, around 15 years to 10 years. And when we think about the smartphone and subsequent technologies, this cycle becomes shorter and shorter. This is also partly due to, I think, that world in general. So software is a kind of already between a lot of people that this is technology that is the foundation for a lot of things. So new advancement based on software usually, I would say, tend to have a more easy time basically to getting adopted. Yeah, and then the significant part in this model is not let's say these 5 segments, but that Geoffrey Moore basically said usually these segments kind of you can basically hop from one of those segments to the other. That means when you have a kind of product or you have wanted to introduce a new technology to the market, then you start with the tech enthusiasts first. You find them. These are usually around, I do not know, I think around 5 to 6%. And you try to find them. You go to maybe hackathons or maybe other types of events where you probably will find those people, and where you can meet them, and then you can basically show them your new product technology, convince them that this is a good thing, and that they become basically ambassadors for invention, and then you can use the references from one stage always as an entry point in the second stage in terms of marketing. But what is basically introduced here, and you might have heard this term already. That means what Geoffrey Moore basically postulated was that this referencing from one group to another will not work when you go from the early, basically the first 2 segments we mentioned, to the mainstream market. Because pragmatists, this is this first segment of the main, do not really like basically drastic change or even like disruptive change. They want incremental improvements, and they do not really trust visionaries because they think some kind of dreamers or whatever. Yeah, basically what he postulated, that there's this kind of chasm, which basically makes it very hard for a lot of technologies and come out of the early market into the mainstream market. And the most technologies and products basically, I mean, he uses like very drastic language there, but die, he says something like die on the left side of. So he also postulates an approach, and I think this will be the last dimension to the model. He also postulates an approach that you should use to basically achieve success in mainstream markets. At first, he says, when you have a certain product that serves a certain use case, you should look for a very specific and very small group that you focus on. For example, when we think about Web3s, there's at the moment a lot of use cases that have the potential to reach mainstream. Things like creator economies, NFTs. When we have seen things like the 300 million investment in Niantic the last week, then I think this shows a lot of confidence that this use case and also the metaverse can reach mainstream adoption. We have, of course, gaming, play to earn, and those kinds of use cases as well. So you would then basically choose one of those use cases and then select a very small, very, very small market segment in terms of users and focus your efforts completely on them. That means you take, for example, when you think about the creator, maybe say, oh, I'm an expert in black metal. So we kind of shape our value proposition specific to black metal type of bands or creators and kind of bring this concept to them. And then basically we to have a very focused approach with a very small segment in this pragmatics basically group of users, and in order to basically have a small, he also mentions this or calls it then a foothold in the mainstream market. And from this foothold, then you would try to develop the other spaces. So this is all kind of Web 2-ish. So this is the usual approach that is recommended for a new product or technology to enter the market. And we have seen, for example, with I would say NBA Top Shots or other types of just recent NFT-based use case, we have definitely seen that that this approach is taken and is seems to be already very promising. But I think there's one, my thought then led to a point where I say that some specifics here that I think make it kind of different for a Web3 product to basically customer. The first one is innovation speed. Also in my background, a lot of type scenarios, you would have always a kind of advantage when you were the first mover in a market, because you had like maybe a closed source product, which basically would allow you to kind of have a little bit of head start. Web3 is different. The open source nature, which is essentially in the DNA of Web3, with transparency, security, and all the other aspects, basically leads to a situation. On the one hand, you have, of course, very fast innovation, because as soon as a product appears or a new project appears on the market, basically the whole industry is advanced, because everybody can learn and can benefit from the advancements that those projects have created. So this is on the one hand, of course, incredibly important to the innovation speed of Web3, but on the other hand, and leads to a commoditization, of course, of the protocol layer. But on the other hand, it creates a very constant innovation. Also, this is at the end, of course, for the industry and for the group as a whole and for the market as a whole, a very good thing, because nobody can basically stand still on their achievements. You always have to constantly innovate, and we have seen various cases like Uniswap or others where it was very obvious that that actually a small head start isn't worth a lot. So what this means is at the end, and how does this relate to the customer at all? So what I already mentioned is the competitive nature of Web3. Products have to constantly innovate. So there's a very small first mover advantage only. And this pressure leads them to focus more on the competition in the And whereas this is good to focus on the competition and to kind of try to innovate and try to become better than them, it takes away from thinking about the mainstream market. We didn't talk too detailed about the sizes of the 5 segments, but usually assume that the early market, which is kind of these first 2 groups, is only around 15% of the total market. And already this third segment is basically also already double the size than the whole early market. So from a let's say from an effort point and impact point of view, it might be a good idea to focus on the mainstream part earlier, but as said, the Web3 nature makes this quite hard and challenging because the early market is so competitive. Yeah, second point. Second point is, yeah, most of the products in Web3 are protocol-based, or a lot of them are protocol, and they are at the end multi-segment, multi-sided, and stacked. And we will go over these terms one by one. So multi-segment means basically that they address multiple user segments at the same time. So when you take an app like Compound or whatever, then it usually is a protocol and an application at the same time. That means it focuses on developers that basically use the protocol programmatically, as well as end users that kind of use the application that was maybe built for demonstration purposes on top and use this. So this is usually different in Web2 type products, because in Web2 type products in the early market, you would usually focus on one user segment and would, for example, things like developer interaction, this would usually, or third-party additions, that would usually be part of the offering only at a later stage. So this is different here for Web3 products, as most of them are protocol-based and, yeah, as such, inherently multi-segment. The second one is they are multi-sided. That means we have usually not only one type of users, but we have multiple types of users that basically use the application or use the protocol. Yeah, for Compound, you would see lenders and borrowers, for example, or you would have users and liquidity providers, for example, on other types of platforms. So multi-sided platforms in Web2 and Web3 alike have kind of the chicken-egg problem. That means you basically have to attract both segments at the same time to create value on the platform. It's referred to as the cold start problem. But also, basically those user bases that you have on the protocol or on the Web2 platform create then network effects. And there's a variety of different network effects. There's a lot of great literature on that, but the essence is that network effects defensibility, because this community and the value that is created because of the community cannot easily be copied. For Web3 type of products, however, there are some aspects that make this a little different. On the one hand, we have weaker defensibility because of the open source nature of the protocols and products that, yeah, I've mentioned this already in the first point. And the second aspect is that we have layered network effects. And this basically brings us then to the third point, to stacked. So whereas in a normal like Web2 type context, like when you take a platform like Airbnb or I do not know, or Uber, then usually you would have one network effect that is basically driving the platform. What we have in Web3 is in a lot of situations that we have basically protocols on top of protocols and networks on top of networks. So we have a variety of network effects that are going on in parallel, basically on different layers of the stack. When we take Ethereum, for example, there's the network of, that means all the nodes that are participating, which is already a kind of network effect that is called an interaction network. Then we have on top, we have smart contracts, which are a kind of platform where basically developers of smart contracts and users of smart contracts come together. And when you then composable smart contracts into account, then you even have another interaction network that sits as a network effect on top. Yeah, so how does this relate it to the CSCON, or how does this make the CSCON for Web3 special? So the third thing is that this innovation speed that we mentioned in the beginning already leads to a quite fragmented and fast-moving industry. This by itself is not a bad thing because it fosters innovation, creates a lot of choice in terms of the solutions that I want to use, but it also lacks matching. So typical Web 2 type platforms, they would have a kind of a capability that is usually referred to as matching in the context of network effects. And this can be a thing like an app store or something else that is basically used as a programmatic helper for users, or for, let's say, one side of the platform to find the offerings of the other side of the platform. That means when you have, like, for example, the App Store on the iPhone, then it would connect the app developer with the application users. Whereas, of course, we have by design on Web3 an emphasis on open architectures. It's not as easy as in a closed shop to create such a matching type or aggregation type of functionality or capability. But this lack of capability basically makes it more difficult for users to find the right depth, for example. And this can, on the one hand, weaken network effects, but on the other side leads also to a situation where it becomes harder to cross the chasm, because usually then mainstream type of people do not want to take any additional efforts in terms of I have to find the correct application or stuff like this, or even like getting to know a lot of different alternatives to the same problem that they might have. Yeah, so and the second one is the stacks. Layer 1, layer 2 protocols, and the different stacks of Web3 have a very huge impact on the overall value proposition and network effects. This means that it should be a very careful decision you want to own, because a stack might even be able to create a negative network. When, like on the node operator in Ethereum, you might have high gas fees just because there's actually too much load on the network. I see I have to hurry a little bit. Yeah, so the third part is, or the third aspect here is really community ownership. Of course, here also this is a great advantage and innovation in Web3 that kind of a lot of Web3 products include in their vision already to transfer governance over the products to the users. This sometimes referred to as exit to the community. And Web3 products introduce a lot of mechanisms such as token-based on-chain or off-chain voting systems, DAOs, and other types of programmatic help to basically efficiently govern the community. In relation to the chasm, we have to say that that such a community, on the one hand, can make it more difficult to make drastic changes, because then your product will probably look drastically different for an early market than it will look for the mainstream market. And as soon as you have started to basically, for example, transfer ownership of your protocol or Web3 product to the community, it becomes maybe a lot harder to align the community about drastic changes on the product. So there's always then a point to consider on which type of your journey adoption it might make sense to basically still have a lot of the control over the project, basically divided just a small amount of people, because then you are faster and can more easily make drastic changes to the project, or when it's then the right time to basically transfer the ownership to a community that is aligned under the same vision of mainstream market adoption. Yeah, with this, I basically want to propose 3 things that I think are very important for Web3 products if they want to basically enter mainstream adoption. The first, thinking, and the whole product model is also quite of a product, depending on which of the segments on the technology adoption cycle you sell. So that means, especially as I've just mentioned 2 minutes ago, a product for the early market will look drastically different as a product for the mainstream market. So a product for the mainstream market really has to be very comprehensive, and also has to then include things like, I do not know, services, installation help, on and off ramps, maybe a wallet, all things that are basically needed to achieve the objective that or the value. They all have to be bundled together, and basically a mainstream user expects that he does not have to install additional stuff, for example. Yeah, thinking about or having a whole product approach very early market phases is very important, not only to already think about potential partnerships, and Aidan has explained it really great, and I couldn't phrase it better, that collaboration is about everything. And also for the whole product approach, it's very, very important to collaborate, because I think crossing the chasm will be a joint effort and will be hard for single Web3 products. And so it's very important to start this early and not get caught in this battle with the early market competitors, as I have highlighted a minute ago. Yeah, the second aspect is maybe controversial, but I think we have to be, then when we want to really come to mainstream adoption, we can't oversell Web3. What do I mean by that? I mean that Web3, and we all are aligned on this, provides great benefits and value for not only the society, but for a lot of different aspects of our. But the mainstream market, and we think about a group that is already referred to as the pragmatics, then we have to be intentful of how we basically bring them change, because whereas for the early market, an aspect like decentralization can be a criteria of value, this will not be true for the mainstream market. So for the mainstream market, I would expect that they do not care as we do. So we kind of have to take a different approach to basically bring basically the unique benefits that we see in the technology to them, without to focusing too much on certain aspects of the technology that we care about the most. Yeah, some things here from personal experience. I've been in InfoSec for quite a while. So one point is, for example, for consumer type products, privacy and security is often overrated. A lot of consumers do not really care about that, even if they say they care about that. They actually don't. And when you see the user base of large of Amazon, Facebook, and Google, then this is exactly the proof that most people simply do not care. At least not enough to basically change their behavior. And the other aspect is like, usually users overestimate the value of their solution. So if we just have a product and try to sell a product that basically is the decentralized version of Airbnb, I hope I do not step on anybody's toes now, but then to place this product in the mainstream market, because decentralization might not be a criteria that they value so much or value that much, and then to change from one solution to another, there are studies that show that the perceived value for the user has to be 10x. That means when I have a product and have another product that fulfill the same problem for me, the new or the contender solution or the contender product has to be 10x better for me to basically trigger this change in behavior. Third aspect, also this ties again to collaboration. So we need partnerships, we need ecosystems. I will speed up a little bit. Aidan has phrased this already to a great extent. So mainstream markets need comprehensive products, and we cannot bring them to the market by ourselves alone. So we need partnerships. We must leverage the kind of unique opportunities that to fund ecosystems, and to basically ensure that we can create value propositions that are much more comprehensive than the single product from a single company or the single project from a single organization can provide. Only when we take this approach, I'm very convinced we will be able to get to mainstream adoption. Yeah, one key aspect that I think was not mentioned explicitly here, but is in all these three basically 3 points that we just discussed is accessibility. And this is something that where I really say that this is important for every project. When we have a Web3 type product, then accessibility is one of the key and fundamental things that we have to achieve in order to get to mainstream adoption. And for Web3 type products, this has not only one aspect. This is the functional side you can see here on the left, but it has more like 3 aspects. There's a functional side. This is what you would traditionally see as user experience. We have an economic side. So if we want to have people participating in our networks, then we have to make we have to ensure also economic accessibility, which is at the end you can phrase this affordability, for example. So the transaction fees have to make sense for users. Also requirements for staking or requirements for node operation have to be as low as possible to basically easy as possible for that, or enable as many as possible people to basically join. And then, of course, we have the technical side, which is ties back to the point I mentioned that basically developers and users are here are basically addressed at the same time by protocols or Web3 type products. And technical accessibility then ties back to points like libraries, like SDKs, like learning and education material that is really needed in order to basically foster and flourish an ecosystem around the protocol that we have. Yeah, maybe on a closing remark, also, of course, accessibility is a key topic here for us at ChainSafe. As Aidan has already mentioned, a lot of our projects aim to improve accessibility of Web3 ecosystems, such as Ethereum, Polkadot, Filecoin. And yeah, I just want to mention a few here, which is ChainBridge, multi-modular and multi-directional blockchain bridge that enables mobility between certain blockchains. This is also a key aspect to accessibility, in our opinion. Second one, files and storage, which provide the easiest way for consumers and developers to access and leverage the unique values of distributed storage. And the third one was already mentioned as well, is our gaming or metaverse SDK that provides the easiest way to basically bridge the blockchain to the games or the metaverse as such. Yeah, and with this, I'm through basically. So I hope there's some questions, and yeah, I hope to get points of view or some things that we might be able to add in terms of things to consider for mainstream adoption. Thank you.
Awesome, Alex. That was an amazing talk. Thank you for your time. And yeah, productization has been such a critical and important topic to ChainSafe. So hearing your insights, applying like Web 2 thinking to Web 3 thinking has been just fascinating. So thank you for your time. Phil had a funny comment there saying it looks like there's space for another developer tool in that chart. We have a lot of questions actually. So maybe I'll do the top 3 just because we're running a little bit behind on time. But first question is from Jonathan Lorimer with 7 upvotes. Well done, Jonathan. Jonathan, great question. Crossing the chasm emphasizes identifying a killer app and being best in class at a narrow mandate. What specific use case should Web3 evangelists focus on, in your opinion?
That's a good question. That's a good question. At the moment, my definitely, I mean, you do not know what you don't know, so there might be something coming up. From the use cases I see right now and that I have mentioned, I would definitely see NFTs and a wider adoption of NFTs. That means not only, let's say, utility tokens, social tokens, but also bringing them to virtual realities, for example, as the most promising use case as of now. And the second aspect is very interesting on the question. This is like, actually, it's like Jonathan wrote here that the original model basically promotes that you should be best in class in the early market before you. And I thought about this a lot. And I think, to be honest, as we have this high innovation pressure in the early, I think it's in the leader. It's not mandatory to be class, because the advantage you gain from being best in class is not the same in Web3 anymore. So it's, from my perspective, also not so important to be the best. You should be one of the leaders, but I think it's not mandatory to be basically best in class before you approach mainstream. And I hope when this is I could bring across is that really mainstream adoption should be taken as early as possible, because it will make life easier at every stage.
Thank you for that. One more question from Dan. Do you believe that Web3 technologies and the capabilities they provide can and maybe should disrupt the traditional models of product development and management?
I think definitely that, for example, this is already happening. That means, to a large extent, traditional, let's say, product processes like discovery, where you work with users together in terms of finding out, hey, what is potential problems or potential opportunities that we can address. Finding basically new capabilities that can add value to the product by using Web3 mechanisms like this very transparent governance, this very transparent voting schemes that you can have. You basically, I would not say you take away a lot, but it makes input and feedback collection and prioritizing of efforts a lot easier, and makes it a lot more transparent in terms of which are initiatives where most of the community sees value in, and which are maybe initiatives that just a small amount of definitely product development product will benefit dramatically from Web3. And that's probably a good topic for a next talk, I think.
Amazing. Thank you for that. I think we'll have to maybe, if one of our help desk people can save some of these questions, so perhaps like Alex can address them like a blog post or an article later, that would be amazing, just because we have to kind of move ahead with the schedule. But Alex, thank you so much for your time. That was a super informative talk, and it seems like a lot of people really enjoyed your presentation. So thank you very much again.
Thank you. The conference, and see you soon on the floor.
Okay, bye. Awesome. And maybe we can get him to stop share screen. Oh, just did it on its own. Perfect. Awesome. That was an amazing talk from Alex. Just a reminder for our audience here, please ask your questions over in the Q&A section. If you want to jump to the networking part of the event, you can go to the events drop-down menu somewhere here, and jump into to another building to meet other people, meet other chain safers outside of the presentation. So coming up next, let me pull up my notes here. We have representation from the Amino Foundation, Brandon Case, and I hope I don't butcher the pronunciation of his name, Joseph Spadavecchia. So Brandon Case is the first engineer at O1 Labs building Amino protocol. Before O1, he has worked as a software engineer for Highlight, which was acquired by Pinterest, Facebook, and Mozilla. It's a nice portfolio. Brandon is excited about the safety and clarity for strong, statically typed functional programming techniques and what they can bring to the software industry. Brandon has enjoyed growing O1's engineering team around these principles. Now, Joseph Spadavecchia is a cryptography engineer at O1 Labs working on the Amino protocol. Prior to that, he was a principal software engineer at Akamai Technologies, writing HTTP proxies and conducted research on decentralized peer-to-peer systems at the University of Edinburgh. They'll be talking about Mina subsystem pathing and deep dive into Oroboros Samasika consensus. That's a mouthful. And what will surely be a deep technical talk for the consensus and engineering nerds out there. Brandon and Joseph, I invite you guys onto the stage and feel free to take it away. Hey. Whoop, whoop. Welcome.
Thank you. While we're waiting for Joseph there, start sharing my screen.
Perfect. I'll take myself off stage.
Okay, I think folks can see. I guess Joseph, you can join in the middle when I hand it off to you as well. But cool, I'll jump in. Yeah, Joseph, feel free to switch your camera on, or you can wait. You just chatted me. I'm gonna get started. So cool. Thank you for the introduction. So Joseph and I actually are we're doing work on the Mina protocol, but not employed by the Mina Foundation. We're employed by O1 Labs, which is an organization that is helping to build the Mina protocol. So right, so we're talking about Mina subsystem pathing, which is just a phrase that I came up with to talk about, to sort of allude to the idea of organizing the work on the Mina Rust client. And then we're going to focus on one of these subsystems, like on one part of one of these subsystems around Oroboros Samasika consensus. So for background, ChainSafe is building an alternate Mina client in Rust, which we're really excited about. And O1 Labs was tasked with specifying, describing, and pathing the work to be done, such that the work on the Mina Rust implementation will get us to a secure browser node before it gets us to a full implementation that can produce blocks and fully participate in the network. Many people may be unfamiliar with Mina. I think there will be plenty of talks on it throughout the conference, but just to give like 5 seconds on it. Mina protocol has the world's lightest blockchain. So in 22 kilobytes, we can succinctly represent the blockchain state in a way that is fully trusted. So you don't need to trust your peers. So basically, this browser node can realize the full security of a typical node in a cryptocurrency network, but we don't actually need, we don't need all the state, we don't need all the typical resource requirements of a full node in other protocols. So this is something that doesn't have a formal implementation yet, and we want the Rust implementation to get there on the way to getting to the full implementation. And then secondly, we want to optimize this path of work such that the most stable parts of Mina are re-implemented first, because by stable I mean like the protocol is evolving. Mina is working on a smart contract layer, and we're refactoring our networking layer. So there's a lot of things changing, and we don't want to waste any time on the implementation side or the specification side doing something that's going to change. So so as part of this work, we're creating a specification, and we want to give you a sense of like just some of the interesting nuances that come up in this. So in this talk, I'm going to talk more about the subsystem pathing. So this is kind of like a higher level overview of Mina, the inner workings of Mina, I guess. And then Joseph is going to talk about just one piece of the of one of these subsystems, which is part of Oroboros Samasika. Okay, so subsystem pathing. I love that. I love that phrase. As a reminder, we want to get to a secure browser node, and we can just not think about things after that right now. And then we want to optimize for the most stable parts. Okay, so the way that I want to show this is to talk about how the Ocamel Mina client works. This is the primary implementation. Mina's in mainnet, and there are plenty of people running these nodes. So the if you're not familiar with Mina, maybe it wouldn't be easy to come up with this list, but bear with me. So, but I am. Okay, so the Mina node, it's a node in a peer-to-peer network, so it talks to other nodes with some sort of networking layer, right? And before messages get sent and after they're received, we have to serialize and deserialize those messages. What is one kind of message? Well, transactions in the network is one. Mina, the way that we can achieve this succinctness is by creating recursive zero-knowledge proofs. So there's a prover component that performs this this proving action, and specifically there's an actor in the network responsible for proving transactions, and those are snark workers. And the other thing that nodes in the network create proofs for are blocks. And so there's a block production system that's attached to the prover that also compresses the blockchain using these zero-knowledge proofs. So a block producer can create a block. They can send it over the network. When it's received, the first thing we need to do is we need to verify that the block is valid. We need to make sure that the data is what we expect, and we need to verify the proof. And then once the block is a valid block, we need to decide, is it better than one that I've seen before, or where does it fit in the blockchain? And while Mina does have a succinct representation, it has probabilistic finality, the Mina protocol. So we can throw out history after like a bit of time, but the very most recent history, we have to store all the forks. And there's a data structure called the transition frontier, which is actually kind of a poor name these days, but this is what we call it in the code base, that stores this recent history. And at every point in this recent history, and at the point of finality, we have a ledger which has all the accounts in the network. It's the account database basically, and there's some other state. And in order to move the state of the world from one state to the next, we apply transactions, and that sort of reifies the notion of the state transition in the system, and that sort of closes the loop. So this is one way to view the different things that the Mina client does at sort of a high level. And if we look at these subsystems and we want to work our way towards a browser node, we want to think about not using too many resources. So both on the time and space side of things. So we shouldn't produce blocks. That's very resource intensive, and you need a bit of extra state. So we can just remove that. We also don't need to behave as these snark worker actors on the network. We can rely on other nodes for doing that, so we can remove that. Now nothing's relying on the prover, so we can take that out. And it turns out the transition frontier, we really only need it in the current sense anyway, when you're producing blocks. So we can take that out as well. And now we're left with the components that should get us to a browser node, which is great. So okay, so we have these components, and now we can think about which ones are very unstable, like what is changing in Mina. One thing, like I said, the Mina protocol, and O1 Labs is doing a lot of work on this, is adding a smart contract layer called snaps. And in a sense, this is just programmable transactions. So of course, transactions are changing a lot. So this is probably the most unstable part. Even when we ship an MVP, maybe it'll change in a hard fork after that. The networking layer also, I mentioned earlier, is undergoing a big change to improve performance in Mina. So that's not super stable in the sense of it shouldn't be implemented in its current form. The ledgers in the other state, this is mostly staying the same, but the account records themselves are changing with the new smart contracts. So this is, let's say, like 50-50. Block verification, again, like mostly the same. The actual snark under the hood is changing to support this general computation. But otherwise, the block headers and things are staying the same. Block selection is almost exactly the same. Consensus isn't changing at all. And then serialization as well as, well, we're keeping it the same exact protocol. So this is literally not changing at all. And this ordering that I just showed is actually, well, I guess we're done. It's optimized now. So I presented it in backwards order, but the recommendation for O1 Labs on how the work should be structured on the Mina Rust client is exactly this: that first work on serialization, then work on block selection. This is the consensus part. Then block verification. Afterwards, the ledgers and other state, the networking, and then finally transactions, transaction application, and all of the last loose ends to make something usable. So yeah, I hope this was a good way to get a tour of like Mina, get a sense of the work on the Rust client. And now I'm gonna hand it off to Joseph, who's gonna just give you a sense of within the block selection subsystem. There's the Oroboros Samasika consensus mechanism, and Joseph is going to talk a little bit about that and about even within that one specific aspect that's super interesting to give you a sense of the kind of interesting problems that we're working on. So I will pass it off to Joseph.
Thanks, Brendan. Just sharing my screen. Okay, right. So now I'm going to present some slides about Mina protocol's consensus algorithm, which we call Oroboros Samasika. Okay, so just to outline the structure of this talk, I'll give you a quick overview of Mina consensus, its goals, and some of its contributions. Then we're going to dip into an interesting problem that illustrates kind of challenges that you run into when you try to take a consensus protocol and make it succinct. And then there'll be some concluding remarks and pointers to further information if you're interested. So what is Oroboros Samasika? Well, as the name would suggest, it's an extension of Oroboros to the succinct setting. And it's the first succinct consensus algorithm in the same way that Mina is the first succinct blockchain. This isn't my work. This is the work of many others. Some of the founders of O1 Labs and the Mina protocol, but many others too, developers. There's been a lot of contributions from a lot of different people that have gone into this. And what I will talk about today is, as Brandon alluded to, it's just a small piece of a small piece. But nevertheless, I feel like it's one of the most interesting parts of the consensus protocol that really makes it possible. So with that in mind, let's move forward. So the goals for Samasika are what you would expect. It's trying to be highly decentralized. Because it's based on Oroboros, we're trying to obtain the security guarantees that Oroboros provides and continue those. And we're trying to also avoid things like slashing heuristics like that. And what Mina contributes really is, the main thing it contributes is succinctness. So Samasika is taking Oroboros and extending it to the succinct setting. And what that means, just to kind of rephrase it in a different way, it means that nodes or peers can join the Mina network and they don't need to download the whole blockchain to get full node security. So we're able to offer a really high security guarantee without having to download 200 or 600 gigabytes and do all the verification. So you can just jump in and out of the blockchain easily, and you can just grab a zero nodes proof and validate it in constant space and time and have full verification, which is a really great thing. Samasika itself actually kind of makes two contributions, not only succinctness, but it has done some things in the realm of self-bootstrap, which are pretty interesting. But for the purpose of this talk, we'll just focus on succinctness. Fun fact, Samasika comes from Sanskrit, meaning small or succinct, so it's a good name. And okay, so now we'll kind of talk about the problem. It's always good to have some sort of motivation. So when taking Oroboros and extending to the succinct setting, this is an interesting problem that came up. It's challenging and has a neat solution. And it roots itself in the chain selection algorithm from Oroboros, which requires us to go back in history. This is the so-called long-range fork chain selection rule. And in the next slides, I'll kind of remind us of what that is. But essentially, the thing that causes the problem is our goal. Our goal is to be succinct. And if we're going to be succinct, we don't want to have this history anchoring us down and costing us. So we want to kind of do the long-range fork rule, which needs to know something about history, but without having all the baggage of history. So let's talk about long forks and remind ourselves about the long-range rule for Oroboros. So because Oroboros is using Nakamoto consensus algorithm, there's some randomization, and you can view the blockchain, especially at the tip, as kind of like a randomized kind of branching structure. And if you follow the blocks back to the genesis block, to the root, it's kind of like a randomized DAG pointing backwards. And the important thing about chain selection, it's really the core of any consensus algorithm. It's the way that all the different autonomous peers agree on what is the current state of the system, what is the canonical chain. The thing that's really important about it is that they all agree in the same way. And in order to do that, there's a primitive, which is just called chain comparison, that has to happen the same way for every peer. And just to remind ourselves of what that is, let's just look at a simple example. You have two chains, a red chain A, a blue chain B. And if you follow these back in time, going back towards the genesis block, eventually you arrive at a fork point, the point at which these two chains diverged from a single chain due to randomization in the network. And the question that all the peers have to ask is which chain is better? And they all have to answer in the same way. And Oroboros Samasika has two different rules. It has a rule when the distance to the fork point is small, called the short range rule, which is quite trivial and isn't really much of a problem for us. It can be handled very easily. There's no challenging problem there. And a long range rule, which is the one that we'll discuss here. And for the long range rule, effectively, you just check what the length is, and if it's over some threshold, we apply that rule. And the long range fork rule says something fairly simple, and I'll try to give us some intuition about it. It just says, select the chain with the highest density of blocks in the critical window. The critical window is just a window of time after the fork, in which that's very important because it's the time at which, if there were like an attack on the network and an adversary was trying to do like a hidden attack and made a fork, it would be a period of time when the adversary would have like a low density of blocks because the main chain would have more block producers and more activity. So in this window, the intuition is that the honest chain's density for the critical window is overwhelmingly likely to be higher. And similarly, the adversarial chain's critical window density will be lower, a lot lower. So this is how Oroboros works. But for the succinct setting, this is a problem because, well, it's not that we don't have history. We actually just don't want history. So how do we approach this now? And this is kind of cool how Mina does it. Just to take a step back, I find this diagram really cool and also useful. This thing on the left that shows kind of this conceptual diagram of like a blockchain state over time. stacking up and how the power of zero knowledge proofs are able to compress that down into a single state and proof. And this appears on the Amino website and in some of our documentation. I think it's really cool. And when I first saw it, I thought that actually the thing on the left, within each of those boxes, you could think of having the whole DAG of chains and things like that. But actually, that's not what it is. And this is actually really helpful for what we'll discuss next, is that actually it's just the recursive proof for one chain. So what Mina is actually doing is it's making succinct every single chain. And then the algorithm, the consensus algorithm, Samasika, is making sure that we pick the right one. And so actually it's taking these chains and just compressing them down to a succinct block or a succinct chain that kind of gives you a proof of the history, but you only need one block. So with that in mind, what we actually want, or what we actually have, is something like this when we do chain selection. We just have 2 blocks and they're proofs. That's the pie there. And we want to be able to figure out which one has the, during a long range fork, which one has the, the higher window density in a critical window. So in other words, we just want to avoid the arbitrary's very low density critical window. And so Mina's approach and solution to this, and we're just going to give a flavor of it here. There are a lot more details in the original publication for Mina. But here we'll just give the flavor and try to convey the idea, is to have each block, i.e. succinct chain, also track the chain's minimum window density. And if you have the minimum window density over all time back to Genesis, and the adversary's window is going to be very low density kind of window that should be the lowest ever seen, then you can apply Oroboros's long range fork chain selection algorithm, which is to just select the chain with the greatest minimum window density. And therefore we can avoid the adversarial critical window. Okay, so that's what we want to do, have this minimum window density as part of the block and part of the proof on those succinct nodes or succinct states. But the question is, how do we do it? And Mina does it in a very clever kind of iterative way so that it doesn't require any history to build this up. And every block that's added on top of another one, it's using the recursive proofs, and it's using the state in the previous block to do it in an iterative way that doesn't require the history. You just need to know the previous block and the current block. But the way I'm going to illustrate the algorithm here is just to convey how it works. I'm going to show it in a different way that will show the previous chain so that we can understand how it works by seeing it all at once. So how it works is, well, in Oroboros, instead of just being concerned with height, we actually divide time up into slots. And this is really important for the security proofs for Oroboros. And we start building from that point with Samasika, but we extend this idea, and also we use this idea in Samasika's own extension of these security proofs. And what we do is we take the time divided up into slots, and we define a new abstraction called a subwindow as k contiguous time slots. So for the purpose of this illustration, just to make it easy, we'll choose k equals 2. So now we've divided up time on the right into 5 subwindows, SW1 through SW5. And then what Mina does next, or rather Samasika does next, is it lets the subwindow density be the number of non-orphan blocks within it. So to illustrate that, consider our red chain, the A chain. And if we extend over those subwindows, we can see how many blocks are in each subwindow, and we can actually just count them. So we get this, 2, 2, 2, 1, 1. Those are the subwindow densities for the A chain. We can do a similar thing for the B chain in blue, 1, 2, 2, 1, 1. And then the next step is to define the actual window, the sliding window, as W contiguous subwindows. And for the purpose of illustration, we'll just do the simple thing and make W2. And when we do that, the next step is to let the sliding window density, the window density, be the sum of its subwindow densities. So for the A chain, just adding 2 and 2. For the window 3, and for window 2, we add 2 and 1, so we get 3. And for subwindow 1, we just have 1. We do the same for the B chain. So now we have a window density, and we've defined windows. The important thing to understand is that this is just an illustration, and Mina actually, especially in the publication, is careful how it selects K and W. It selects them in a way that it's guaranteed to capture the critical window, and it's an important part of our security argument. But for the illustration, we'll just keep the numbers simple and the diagram simple so we can get the flavor of what's going on. And as I said before, actually, the way I've just kind of illustrated it here is just showing the whole thing on one kind of linear history. But Mina does it using this sort of equation, and it does it in an iterative way so that, for example, the current block has all the previous subwindow densities, and it knows about its own block's existence. So then it can, from that, do a kind of fancy shift in an increment and compute its own subwindow densities. And then it will have the two of them, and it's able to calculate the minimum of the previous and its current. So this is just to say that things actually happen differently in the code, and in even more elegant kind of way. Okay, so what does each block need to store now? It stores the current sliding window for its chain. And this is just a vector of integers, so the subwindow densities. So for the red succinct chain, it's just 2, 2. And for the blue, it's 2, 1. And it needs to store the minimum sliding window density, which it can update every time a new block is produced. And this is the minimum density observed over all previous sliding windows. So here for the A and B chain, that's 3 and 4. And now each block has everything it needs to select the correct chain when Samasika encounters a long-range fork. And important thing to note here is that the sliding window is just a small list of densities. In fact, in Mina, it's just 11 32-bit integers. So therefore, the resulting structure itself is succinct. And it's a clever solution. And this simple algorithm and structure is able to capture all of that history, or what we needed from the history of an entire chain, which could be years long. Okay, so now to summarize. So yeah, Mina introduces Oroboros-Samasika, and it's the first succinct consensus algorithm. It builds upon Oroboros, adds succinctness. It's fully decentralized and trustless. It has provable security. And a really cool part of the Samasika consensus algorithm, and perhaps one of the most central parts of it, is the minimum window density algorithm. And if you're interested to learn more, there's the original publication titled Coda, because Mina used to be called Coda. And that has, in addition to details about consensus algorithm, all sorts of details about the inductive proof system and the rest of Mina as a whole. And if you want further details about Samasika, you can have a look at the Mina consensus specification, which actually includes some algorithms that are significant that aren't included in the original description from the paper. And with that, I will close. Thank you for listening.
Amazing. Thank you so much to the both of you for presenting on Oroboros-Samasika. I'm surprised myself that I can pronounce that. And also, I'm so happy I pronounced your last name right, Spadavecchia. We have a bunch of questions from the audience. So if I may, I will ask them to you guys. And first one, Jonathan Lorimer, 5 upvotes. Why was Ocamel chosen for the initial implementation, specifically as opposed to other fully pure FP languages like Haskell?
Yeah, I can take this. Yeah, so we chose Ocamel. Actually, so fun piece of history. The initial prototype of Mina was written in JavaScript with flow typing. So for at least the engineers who were working on it, myself included, we didn't want to ship a layer 1 blockchain in JavaScript. So we wanted better safety guarantees. We wanted functional programming, strong static typing. The reason why we chose Ocamel over Haskell is because it is it's I mean, if you give this argument to Haskellers, they'll get mad at you, but sorry. impurity is very easy to drop down into when you need it. So you can write imperative code like C or functional code, and very predictable performance, very predictable fast build times always, and a really coherent type system that you don't have to turn on and off flags and get a version of the language that you like. It's all there. It's all sewed together. And I mean, really the biggest thing over Haskell is that you can write imperative code. So I guess I'll leave it at that.
Awesome, and I'm not sure if Joseph has anything to add there. Joseph, your screen share is still on, so we're getting screen sharing inception. But okay, all good now. Another question from Jonathan Lorimer with 5 upvotes. Is Oroboros Samasika based on Cardano's Oroboros consensus protocol?
Take that one. Great question. The answer is yes. It's based on the Oroboros that we all know and love, or maybe we don't love it. I don't know, but yeah, it's that protocol just simply extended to the succinct setting. So there's things it does that if you want a succinct blockchain, you can't do. If you want to drop history, you need to make some changes. But we've tried to be very minimal in those changes.
And one more question from Anonymous with 2 upvotes. Can the attacker inflate window density artificially? For example, create a high amount of transactions in a short period of time?
So that's a great question. That's something that when I was learning about Samasika, I asked myself over and over again as I poured over the protocol. The answer is no. There's a security proof for Samasika, and essentially the entire process of updating this window as you introduce the next block is completely deterministic from the parent block. And so we're able to check that that block isn't corrupt or doesn't kind of do something to corrupt the window densities, to lie about the densities in order to kind of thwart the blockchain. Not only that, but every single block that gets a proof done for the block will include checks on the window densities as part of that zero knowledge proof. So the answer is basically no, an attacker can't do that. And if you want more details, you can have a look at the publication. It'll go into more details.
Awesome. Well, one more question, why not? From Anonymous with 1 upvote, presumably from himself or herself. Why was a variant of the Oroboros protocol chosen as the consensus algorithm?
I can take this one. Yeah, so when we were thinking about consensus algorithms, well, I guess another piece of fun history, the first implementation that just internally for testing was proof of work, just Nakamoto consensus. It's super easy to implement, but the team felt, myself included, that we didn't want to create another proof of work chain. There's a lot of downsides to that. So we had this goal, proof of stake, right? And one criteria that we had as we were working on Mina, as we were designing it, was like do as little new things as possible. Like we already had succinctness, and that caused a lot of parts of the protocol to be unique and new. And we wanted to take pieces that we knew were that were well designed. So we looked at existing proof of stake protocols. At the time, Oroboros was the one that had a formal specification. It wasn't encumbered by patents. It had these great properties around decentralization, and we were impressed by the amount of like rigor that had gone into the creation and the specification and all the proofs about the protocol. So we use that as our starting point. And then of course, as Joseph talked about, and if you dig into the paper, you'll see we had to change it a bit for succinctness. But another great property of it is in our case, we don't need slashing or bonding or anything like that. So we just got a lot of nice properties out of it.
Amazing. Thank you guys so much for stopping by. That was an amazing talk. Thank you for your time. And yeah, feel free to stick around and listen to some of our other talks. We've got more people from the Mina community and foundation presenting later. So thank you for your time.
For having us.
Wicked. And then there was me. Okay. Up next, I'm gonna butcher this name, I know for sure, but I'm gonna try. Up next, we have Vukashin Vukoji. Vukoji. Vukashin Vukoji. Vukashin. Oh, hey. I know I'm butchering your name. I'm so sorry. I'm just gonna do a quick little intro, and then I'll let you take it away. Okay. Vukashin heads ecosystem growth at Protocol Labs. He previously founded Tenderly and is now also advising as lead product of tokens and smart contracts at Cardano. A perhaps interesting story about Vukashin and how he ended up at CSCON 1. Myself and two other colleagues randomly stumbled upon Vukashin at a coffee shop in Lisbon at the end of LizCon a few short months ago. Even though he worked at Protocol Labs, a partner of ChainSafe's, most of us had never met before. Nevertheless, he stunned all of us with his deep technical knowledge and passion for decentralized infrastructure. The moment I met him in Portugal was a sort of welcoming party for me personally at my first crypto conference ever. This was the sort of caliber person I was to expect to liaison with moving forward, but also the sort of open and welcoming soul that would be willing to just have random crypto conversations with a bunch of nerds in a coffee shop. So Vukashin will be talking today to us about decentralizing the data center. Vukashin, take it away.
Thanks for inviting me and such a great introduction as well. So yeah, today I'm going to talk about the Web3 infrastructure. But when I say Web3 infrastructure, that's very general and ambiguous. So I'm specifically going to talk about how we are seeing the data center evolve and allow multiple networks to connect through the data centers that are actually being run with what we call miners today. So I'm going to share my screen and go through these slides. So yeah, this is not necessary as I got the intro already. Yeah, so where we are today with data centers. So most of them today are owned by big tech companies, either for internal use for training large amounts of training models with large amounts of data for internal uses, or renting those through cloud services that are mainly owned by those big cloud providers and tech companies. So on the other side, we have very few still remaining data centers that are trying to somehow compete just with infrastructure. But slowly, all the medium ones and small ones kind of died off because the business models where you're renting or selling a particular server for a particular time, that doesn't work anymore. Because what we're selling today is abstractions on infrastructure that is running on the cloud. And this is where the cloud providers, of course, dominated. And the smaller data centers, which by nature were only basically real estate businesses rather than tech businesses, couldn't compete at all. And many of them had to basically shut down. And now we are slowly, in my opinion, seeing a renaissance in data centers again because of a couple of reasons. First of all, there is a shortage of chips in general. So any hardware that you had left from the past couple of years, that's still good, and it's still going to be good for a couple of years. And on the other hand, we are also getting to a point where we are able as a humanity to share the resources between things that are not necessarily owned by big meaning that we are able to share computing resources with things like Golem and networks that a cache that are actually allowing us to have an abstractions over those. The sad part is that currently the situation is that probably less than 10 organizations are controlling all of the data that we are storing as humanity, mainly because of those development tools that were basically each other, meaning that we have, for example, the VM and some hypervisor that is actually managing those VMs on hardware that is owned, for example, by AWS. Development tools, like initially those were just load balancers, but then those became more complex, where you had like managed Kubernetes clusters and things like that, where you're getting to a point now where the developer is even aware of what's happening under it. But the issue of those is that we are now at a point where one developer can actually like build something that is hyper for like hundreds of millions of users, but that developer has like no clue on how that is being executed on the machine itself. And the issue is that when we are trying to like change the paradigm, how we are actually doing computing, it's very hard to convince someone to put like 10x the effort just to build something that is not being owned by Google or all the other tech companies. Because of that, when we have like a new developer entering the like the entire like software ecosystem, the default thing is going to be to go to like some pass for your backend, and maybe even use something like Firebase, and not even noticing what's happening in the background, which is sad because that basically puts us in a spot where it's going to take us much more time to actually get in a position where we can change it. So instead of taking us a couple of years just to develop the things, we need to like spend probably 5 years to get to a point where it can be fully competitive with what we. The issue with centralized storage is not because it's centralized; it's because of the way that that infrastructure is being managed, and because of the legal constraints that you have when you're basically running a server. So meaning that by default, like all the data that you're storing on your servers, in a way it's yours. Of course, you can have some terms of use that are like massaging that a bit, but at the end of the day, you are controlling that data. And very few companies like are controlling like massive amounts of data, also sparse all across the globe, giving a lot of power to particular like countries, which is becoming very problematic in the past year, and that is getting us in a spot where we are like risking to get in very like unpleasant situations where we have particular countries that might have like a reason to like detach themselves from the internet, or where we have like very strong firewalls that are actually like preventing us from having an internet that is neutral all across the globe. But on top of that, also like the development tools that I mentioned are also like inheriting those properties and giving like the same legal and ownership of the data constraints to the final product that those developers are building. What we do instead with decentralized storage is we want to create an equal playing field for all the participants, where like the data center operators, the developers, the users can like access the protocol in the same way. Because of that, we have very strong rules that are dictating how that protocol works. And because of that, we are able to align all the incentives in a way that everyone starts thinking about how to like maximize the value of the ecosystem, rather than how to extract most of the value in the single transactions that are happening. Meaning, like, I'm not selling anymore like a server for, or like a VM, or like a cluster for X, and trying to like capture a percentage of that X. Rather, I'm thinking about how am I gonna store this data set? Can this data set be leveraged by other users? And if that data set can be leveraged by other users, I could also like possibly think about creating some data DAO around that data set, and maybe monetizing the fact that I have like curated that data set and figured out what data set is important for humanity to store. Also, a very important thing that is actually like bringing the renaissance in the traditional data centers is the fact that now we don't need to like have centralized tools that are only running on the cloud providers. Rather, we have tools that can run on any data center operator, because those are tools that are just built for the ecosystem as a whole, rather than a particular entity. And that is going to speed up, in general, like the progress that we are going to be making with the storage and computing by a lot. Because now I'm not competing between tools. Now I'm teams that are actually building things together to actually and like merging all the efforts into one. So yeah, in order to get to a point where we can actually change that, what we need to do is we need to focus on 3 particular things. On today's, I'm going to focus on the last one. But other than the infrastructure, we also need to have like the tools that developers working, for example, on mobile apps have to use in order to leverage that infrastructure without having to worry about all the details and having like a nice abstraction layer around the retrieval and storage and networks. Of course, we need to bridge storage with computing. Otherwise, storage value is very questionable, and also like computing value per se is very questionable as well. If we need to like retrieve and store data from the computing network to the cloud all the time, and at the end, we also need to make sure that that is actually like working on every data center, also known as miner in blockchain space. So yeah, how do we actually do it? So we need to reduce the barrier to entry to participate as a Web3 data center operator, meaning that as a miner, I can't really like do DevOps work and figure out like how to provision particular nodes on which particular machines and so on. So that needs to be abstracted away for the miner. This is something that I'm particularly focused on by incubating a team at Protocol Labs. Also, we need to abstract away the storage and retrieval. Historically, everyone knows that storing a storage deal on Filecoin was very hard. And this was also because we tried to make it such that it is very flexible and everyone can basically do whatever they want. And we have like a couple of implementations on how to actually store those storage deals to Filecoin ideally, how to like split the multiple sectors and what are the ideal ways of actually like doing those storage deals with those sectors on the network. But yeah, that's a core problem that now we think we have figured out. And then what we also want to make sure is that because of the high collateral requirements that the Filecoin network has, with good reasons, because we want to have a very stable base of data center operators that are actually going to be there like no matter what. And the best way of doing that is by having them have like a lot of collateral that they are going to lose in the case of them not like obeying the rules of the protocol. On the other hand, we also need to massage that a bit. We can't really have that barrier to entry that high. Otherwise, the network is not going to grow fast enough to allow humanity to have like the largest storage network in the world. So what we do is we leverage things like reputation, both on-chain and off-chain reputation, to just reduce the risk by a bit and allow, for example, users in DeFi to do revenue share with those miners, or to allow particular institutional funds to invest in particular data centers because they see all the logs that those data centers have provided, and with some statistics we can see that those are likely not to fail. So that allows us to accelerate the growth, but it also allows us to leverage that anchor collateral that is there to onboard the other networks. Because if you think about what's necessary for you to do some computing on that data center, in the beginning, it's going to be like you need to figure out like how to make sure that that miner is reliably always running that compute. So instead of like building your own like protocol that has like collateral requirements or other like mechanisms on how you're incentivizing that miner to behave rationally, you're instead relying on the collateral that is already stored on the Falcon network. And we have seen that this was particularly useful for some rendering networks, some computing networks that did not actually have like collateral requirements at all. So where we are today. So we have 13 exabytes of storage capacity, and this is spread across the globe. But of course, there is more in Asia because it turned out that like in Asia, it was much easier for miners to like buy equipment and figure out like how to mine. And also, since that started very early on in that ecosystem, it spread very fast. And that growth is something very similar to what happened back in the days mining was like very popular, or Ethereum mining. Like it grows so fast in a couple of months, and then of course it stabilizes when like more and more miners get in the ecosystem, of course, because they are sharing the rewards that they are getting. But this basically, I mean, it's a sign that we can get to a point where like computing and storage can be so cheap that we are going to be unlocking incredible use cases that today are just not feasible. Because cloud providers today are not charging you like what's actually, they are charging you 10x of what that really costs you. And they are just absorbing those, I mean, in that way, they are basically absorbing the cost that they have for development of the tools and for marketing, sales, and so on, which is not something that we need in a decentralized storage network. By the way, this is 13 times more than what cloud providers had the first year of operations, because 13 exabytes was onboarded in the past 12 months, since that was when the Falcon network was live for the first time. So it's super fast. We are not realizing that because everything is moving so fast, so we are not even looking at that number that much. But when the cloud was growing, much slower. But yeah, it was long ago. So a bit about like how that looks in the data center. So of course we have like a storage network, and we have like a data center where we have multiple hosts, and those machines are like very different, like GPUs. Some might have like high memory, some are like storage nodes that basically have like a bunch of hard drives that are redundant and have like more redundancy than the other nodes. And people would think that the Falcon network looks something like that. But actually it's not. Like it takes a lot of effort to get to a point where you can actually have like a committed capacity, which means like that particular capacity is committed by the miner and can be used for some verified storage deal that is basically some data that is useful to the network. Instead, how the data center, instead, like what we have is we have storage, we have proofing, we have sealing, and all of those, of course, have like very different resource requirements. But at the same time, we have, yes. So just to go over like quickly, because some people might not be completely aware of what's happening here. So first of all, we have like the storage nodes that are making sure that like the storage that is stored on Falcon can be retrieved, and that it is always there. And in case of that not being there, those miners will be slashed. Then we have like the proofing that is being done like every 24 hours, making sure that like the committed capacity that is committed is actually committed, so that has to uniquely prove every 24 hours that all the sectors that he has committed are actually there. And then in order for those two to be possible, the onboarding of the storage needs to happen through the process of sealing. And the process of sealing that has like very different resource requirements, because some parts of the sealing are very high memory, and high frequency cores are required for that because they are single threaded. while others can be many CPUs in parallel or on advanced GPUs that have like CUDA cores. So at the end, we get in a situation where we don't have like anymore just the storage nodes, but we have like a bunch of different nodes running on different machines, depending on the stage of the data center. Meaning that if we have like committed to all the storage capacity that we have in the data center, then we probably are going to have like mostly proofing nodes and nodes that are doing just managing the storage. But if I'm onboarding storage, I need to have like many sealing nodes as well. So from there, where we want to get is to a point where other than just managing storage, we also have computing that is actually like interacting with the storage. So we are going to have some compute network, just to be fair towards all of the network. It's going to be a compute network X. And then we basically need a way for whatever is computed on that compute network, and of course, like that compute deal is going to happen on that network, and someone is going to pay for that computing resource. Then we need to find a way to efficiently store that on the Falcon network. So we need to have like a storage and retrieval layer that is actually like managing all the interactions that are happening with the Falcon network, negotiating storage deals with particular miners based on some characteristics that are important for that customer that is interacting with the computing network, and so on. So we're just trying to decouple like all of those complexities in a way that the computing network or a developer that is actually like building something that needs to be computed on a compute network and stored on Falcon is not managing all of that complexity himself. Otherwise, it's not going to happen. But the most interesting part is that, the most interesting part is that all of those are going to be running like on the same data center. So like the bandwidth that is available from the compute network to the Falcon storage network is very high. And at some point, if you're referencing data that is already on that data center and you're referencing those that data through CIDs, you're most likely going to have like like orders of magnitude faster computing, depending, of course, on how challenging the compute job is, because you're able to like retrieve it right away from the same local network. A bit about Estuary. Estuary is that retrieval net. It's not yet a network, but it's that retrieval layer that actually allows you to store data to the Falcon network, but also retrieve data from the Falcon network through IPFS. And it's also managing the caching of that data. So for example, if you have stored something on Filecoin through Estuary, and that something is being used by particular users, it's always going to be cached on IPFS Estuary, and that logic is managed by Estuary. So you basically, as a compute network, you're not even like aware of what's happening on Filecoin. All of that is being abstracted away by Estuary. So yeah, of course, the importance of having everything on the local network are many. First, because like data is growing so fast that at some point we are going to start hitting infrastructural issues, like in the context of like the amount of fiber that we can dig into the ground is not going to be enough. Like Starlink is not going to be enough. We will need to start thinking about how do we do computing locally rather than always retrieving that from the internet. Especially since data sets are growing, it's becoming practically impossible to like retrieve something in a relatively short amount of time. Yeah, so this is the situation we are now, but with computing, we actually have like different nodes that are running the computing network based on like the resources that are available there. And then we have like the Estuary layer that is allowing, which can also run like on a single machine and talk to the other nodes. But in this particular case, it's running like on each of the machines and managing how that is being written to Filecoin. But other than that, we need to have some logic which is something that I'm particularly interested about, which I'm working on, that allows us to do some more those nodes, which means that we need to be able to get to a point where we can receive a particular job, and that job is scheduled to a particular network, which can be multiple networks. And then we get to a point where basically we are thinking about how to maximize the resources that are available to that